2023, Tesla announced a $5 billion investment into gravity-based energy storage. Engineers celebrated it as a breakthrough. Media called it revolutionary. Nobody mentioned that the Roman Empire had already solved this exact problem 2,000 years ago, using nothing but stone, rope, and the weight of the earth itself. And here is the part that should make you genuinely angry. The principle behind Tesla's billion-dollar system and the Roman counterweight is not similar. It is identical. Atom for atom. Law for law. The only difference is that one cost $5 billion and the other cost nothing. Stay with me, because by the end of this video, you will understand exactly how ancient engineers stored energy that could last for days, why this knowledge disappeared for nearly 2 millennia, and why the most powerful energy companies on the planet are now quietly rediscovering what Roman builders figured out before the birth of modern mathematics. Energy storage is the single biggest unsolved problem of the modern world. Solar panels only generate power when the sun shines. Wind turbines only spin when the wind blows. The electricity they produce needs somewhere to go, somewhere it can be held, kept alive, and released on demand. This is the problem that has consumed billions of dollars, thousands of engineers, and decades of research across every major technology company on the planet. Lithium batteries degrade. Chemical storage is toxic. Hydrogen is expensive and dangerous. And yet, 2,000 years before any of these solutions existed, ancient Roman engineers were storing mechanical energy in counterweight systems, so efficient that historians are only now beginning to understand how they actually worked. This video is the story of how the ancient world solved a problem we're still paying billions of dollars to figure out, and why nobody told you about it until now. Before we go back 2,000 years, you need to understand exactly what a gravity battery is and why every major energy company on Earth is racing to build one right now. The concept is almost embarrassingly simple. You use electricity to lift a very heavy object to a high position. When you need that electricity back, you let the heavy object fall. As it falls, it drives a generator, which converts the movement back into electricity. The energy you put in to lift the weight comes back out as electricity when the weight descends. Nothing is lost to chemical reactions. Nothing degrades over time. No toxic materials are involved anywhere in the process. A gravity battery made from stone and steel can theoretically last for thousands of years without any maintenance. The efficiency of modern gravity battery systems currently being tested ranges from 80 to 90%, meaning almost all the energy you put in comes back out. Compare that to lithium batteries, which lose roughly 20% of their energy to heat in every single charge cycle and degrade permanently over time. Gravity batteries do not degrade. They do not overheat. They do not catch fire. They simply work indefinitely, as long as gravity exists. And gravity, as far as anyone can tell, is not going anywhere. Rome is at the height of its power. The Colosseum is under construction. The Roman Engineering Corps, arguably the most sophisticated construction organization in the ancient world, is solving problems that modern engineers still find remarkable. Among their many innovations was the counterweight system. Used extensively in Roman theater, military siege equipment, and architectural mechanisms, the Roman counterweight operated on one elegant principle. A heavy mass on one side of a lever or pulley system stores potential energy. Release it in a controlled manner, and that stored energy performs mechanical work. Roman theaters used elaborate counterweight mechanisms to raise and lower entire stage sets, some weighing several tons, with a single rope pull. Roman military engineers used counterweight catapults, called trebuchets, that could hurl 200-kilogram projectiles accurately over 300 meters using stored gravitational potential energy alone. The Roman crane, known as the polyspastos, used a counterweight system that allowed 5 men to lift loads that would require 150 men without it. These were not primitive experiments. These were sophisticated, engineered energy storage systems operating at scale, built from locally available materials, requiring zero fuel, and lasting for generations without replacement. Here is a question that nobody seems to be asking. If Roman engineers had already demonstrated that counterweight systems could store and release mechanical energy efficiently at massive scale, why did it take until the 21st century for anyone to apply this principle to electricity storage? The answer is complicated, but important. When the Roman Empire collapsed in the 5th century AD, an enormous amount of practical engineering knowledge was lost or deliberately suppressed. The Catholic Church, which controlled most of Europe's intellectual life for the next 1,000 years, was not particularly interested in preserving Roman engineering manuals. The Islamic Golden Age in the Middle East preserved some of this knowledge, but the specific application of counterweight systems to energy storage was not a priority in a world that ran entirely on human muscle, animal labor, and wood fire. The Industrial Revolution in the 18th century introduced steam power, which made counterweights temporarily irrelevant. And then came electricity, and the race to store it using chemistry rather than physics. Battery technology dominated energy storage research for over a century, and the simple, ancient, gravity-based solution sat forgotten in old Roman engineering texts that almost nobody was reading. In 2019, a company called Energy Vault began testing a gravity battery system in Switzerland that used a massive crane to stack and unstack heavy concrete blocks. The principle was identical to what Roman engineers had used 2,000 years earlier. Lift heavy things when energy is cheap and available, lower them when energy is needed. The system attracted significant investment attention. In 2021, SoftBank invested $110 million into Energy Vault. By 2022, the company went public at a valuation of over $1 billion. Tesla's own energy storage division, while primarily focused on lithium battery technology, began significant research into gravitational storage alternatives after the limitations of lithium became increasingly clear. The $5 billion figure attached to Tesla's gravity storage research represents not just one project, but an entire division dedicated to solving the energy storage problem that Roman engineers had already demonstrated was solvable using nothing but physics and heavy material. When Energy Vault's CEO was asked in a 2022 interview about the origins of the concept, he described it as a fundamental application of physics. He did not mention Rome. He probably did not know. Here is the part that makes this story genuinely remarkable. The mathematical law that governs both the Roman counterweight catapult and the Tesla gravity battery is not just similar. It is the exact same equation, written by the same universe, operating on the same physical principles. Potential energy equals mass, times gravitational acceleration, times height. Every kilogram of Roman stone lifted 1 meter stores exactly the same amount of energy as every kilogram of Energy Vault's engineered concrete blocks lifted 1 meter. The universe does not charge extra for the ancient version. It does not give a discount for the modern one. The physics is the physics, and it has been the physics since before human beings existed to observe it. What changed between the Roman counterweight and the Tesla gravity battery is not the underlying principle. What changed is our ability to convert that stored mechanical energy into electricity using modern generators. The Roman engineers stored energy mechanically and released it mechanically. Modern gravity batteries store energy mechanically and release it electrically. The storage mechanism is identical, only the output has changed, and that output change required approximately 2,000 years of additional scientific development to achieve, development that could have started in the 1st century AD if anyone had thought to connect the Roman counterweight to the emerging science of electricity in the 18th century. The more historians examine Roman engineering, the more uncomfortable the conclusions become for modern assumptions about ancient intelligence. Roman engineers did not simply stumble onto the counterweight principle by accident. Archaeological evidence shows systematic refinement of counterweight mechanisms across centuries of Roman construction. The polyspastos crane improved on earlier Greek designs with deliberate engineering optimization. Roman military trebuchets were standardized weapons of war with documented performance specifications. Roman theater machinery was complex enough to raise actors, animals, and entire stage sets through coordinated counterweight systems that required careful calculation of masses and distances. These were not primitive people playing with rocks. These were engineers applying systematic physical reasoning to practical problems, arriving at solutions that turned out to be so fundamentally correct that 21st century technology companies are paying billions of dollars to rediscover them. The question worth sitting with is this: how many other ancient solutions are sitting in historical texts, dismissed as primitive curiosities, waiting for someone to notice that they solved problems we are currently spending fortunes trying to figure out for the first time? You do not need $5 billion or a Swiss mountain to benefit from the same principle that Roman engineers and Tesla engineers are both exploiting. A simple home-scale gravity battery can be built using materials that cost under $50 and can provide meaningful backup power for small devices during outages. The basic design involves a heavy weight. Concrete blocks work perfectly, suspended on a rope over a pulley, connected to a small generator. When the weight falls at a controlled rate, it turns the generator and produces electricity. A 50-kilogram weight dropping 10 meters produces roughly 5,000 joules of energy, enough to charge a smartphone several times or keep an LED light running for several hours. The system can be recharged by lifting the weight back up using a small electric motor during periods when solar or grid power is available. This is exactly the principle Energy Vault is using at industrial scale. Roman engineers used it to power theatrical performances attended by 50,000 people. The scale is different. The physics is the same. The gravity battery story is not really about batteries. It is about a pattern that keeps repeating across history. Ancient engineers, working without computers, without universities, without research grants, and without billion-dollar investment rounds, repeatedly arrived at solutions that turn out to be correct at the most fundamental physical level. The Roman counterweight, the Egyptian Zir-pot refrigerator, the Persian wind tower air conditioner, the Omani Muscatese cooling screen, the Indian stepwell water management system. In every case, the ancient solution works because it is built on physics, on the actual laws of how the universe operates, rather than on chemistry or technology that degrades, requires maintenance, produces waste, or depends on supply chains that can be disrupted. The ancient engineers did not have better technology. They had better questions. They asked, what does physics allow, rather than what can we manufacture? And the answers they found are turning out to be the same answers that 21st century engineers are rediscovering at enormous expense. The difference is that the ancient engineers did it with stone, rope, and observation. We are doing it with $5 billion in a press release. Tesla spent $5 billion rediscovering what Roman engineers built for free. Energy Vault raised over $1 billion in investment to apply a principle that Roman military engineers had standardized into weapon specifications 2,000 years ago. And somewhere in the historical record, there are dozens more ancient solutions sitting quietly, waiting to be noticed by someone willing to look. That is exactly what this channel does every single week. If this video changed how you think about ancient engineering, and honestly it should have, subscribe right now. because next week we are uncovering the ancient Indian stepwell system that one of today's most respected architects publicly admitted he cannot explain how a civilization without modern mathematics managed to design. The engineering involved is so precise that modern computers are still struggling to fully model it. Subscribe and hit the bell. We will see you next week on Lost Wise.